So let's talk about the electrolysis of aqueous solutions. What do I mean by an aqueous solution? I mean that there is a chemical dissolved into a solvent. Most commonly this is water. So this example here that I've got a nice photo from Wiki Commons about, this is potassium iodide in water. So really what we're talking about today is what are the products of electrolysis of these aqueous solutions and where are they formed? And there are some various rules to help you work out exactly what will form and where. Now we'll need our old friend the Reactivity Series for this one for a little bit of help. And what we're going to do is we're going to run through the rules first, and then we'll do some examples together just so we start feeling a bit confident about how to work this all out. So, number one, at the cathode, which if you remember is the negative electrode, whatever is least reactive goes first. So the least reactive forms first. So looking at this list here, whatever is in your solution, the least reactive thing will go first. Okay, that's relatively straightforward. Let's look at the anode, which if you remember is the positive electrode. The rules here are a little bit more complicated. Thing number one is there a halogen ion present? And if the answer is yes, then you make your halogen. If no, if there isn't a halogen, you produce oxygen gas. Now there are reasons for this, and they are very complicated. Strictly speaking, saying that this is down to the reactivity series isn't entirely correct either, but if we go into that, we're going to be here a very, very long time and things are going to get very complicated and confusing. For us today, leaving it at this is perfectly suitable. It will do you just fine if you just think of this as the reactivity series and these being some rules that you have to follow. Let's look at some examples then, and we'll apply these rules. So if I, let's say, take NaCl, so sodium chloride solution. So it's been dissolved in some water. Basically, this is salty water. So what am I going to make? Well, I am going to make some positive sodium ions and I am going to make some negative chloride ions. But what about this solution bit? Well, the water itself, water ionizes slightly. So you know you've got your H2O. Well, that turns into H plus ions and OH minus ions. It's a reversible reaction. It goes forwards and backwards. But what that means is that we have got sodium ions, chloride ions, hydrogen ions and hydroxide ions all hanging around. Okay. So that means that when you look at the cathode, so your negative electrode, you've actually got your sodium and your hydrogen in competition to be formed first. Now let's just check in with the rules. I said the least reactive goes first. So if we look at our reactivity series up here, sodium is there and hydrogen is there. So the least reactive goes first, so hydrogen will form. So this hydrogen, it will form, and it will form into hydrogen gas. Obviously, we need to do a quick bit of balancing here because there's 2 hydrogens over here and one over here. So I'll put a quick 2 there. Now I need to balance the charges because I've got 2 positive charges over here and it's neutrally charged over here. So let's add in 2 electrons to balance things out. And I'll have a quick check-in with oil rig, just to see what is going on with our hydrogen. Remember, oxidation is loss of electrons, reduction is gain of electrons. So seeing as the hydrogen is picking up and gaining electrons, we can say that it is being reduced. Well, that's the cathode. We will start seeing bubbles of hydrogen gas forming. What's going on at the anode? Well, if you remember the rules for the anode, it says, is there a halogen ion present? There is. So in a competition between the chloride, I'll tell you what, I should make hydroxide a little bit more colourful. There we go. In a competition between these two, the chlorine will always win. So the Cl- will make some chlorine gas. How will it do it? Well, I've got to balance up the number of chlorines. Put 2 there. It's going to drop off 2 electrons like so. So the chlorine is, oops, I'll extend that arrow a little bit more. The chlorine is dropping off some electrons at the positive electrode, and it is being oxidation is lost. It is being oxidized. So what are you going to see with your sodium chloride solution? You are going to see hydrogen gas forming at the cathode. You are going to see chlorine gas forming at the anode. And what are you going to see left in your beaker at the end? Well, you are going to see the sodium ions and the hydroxide ions floating around. So that is essentially going to be sodium hydroxide. So when you do this reaction, what's left in your beaker will get increasingly alkaline because sodium hydroxide is an alkali. Okay, let's do another little example then. Let's do copper sulfate solution. So what's copper sulfate solution got in it? Well, you have got Cu2+, that's your copper ion. And then you've also got SO4 2- ions floating around. It's a solution, so you're also going to have some hydrogen ions, and you are also going to have some hydroxide ions, like so. So at the cathode, our negative electrode, there is going to be a competition between the copper ions. I've done copper and hydrogen the same colour. Whoops. Copper ions and the hydrogen ions to see who forms, who goes first. Let's quickly check in with our rules. Who's going to go first? It says the least reactive forms first. So if we look up here, we've got copper here and hydrogen here. Copper is least reactive, so it's the copper that will form at the electrode. So you've got Cu2+ forming into copper metal, and you'll actually see copper metal start to form around that electrode. So it's forming Cu. How's it doing that? Well, it's going to pick up a couple of electrons to become neutrally charged. What sort of reaction is that? Well, it's gaining electrons, so that is reduction is gain, that is being reduced. At the anode, what's going on? I've got my SO4 2- heading over to the positive electrode, and then I have my OH- heading over there as well. What's going to happen? Well, I've done the colours the wrong way around. Let's put the colours the right way around. So we've got OH minus. That's a little bit more like it. So which one of those guys is going to go first? Well, if I check back in with my rules, is there a halogen ion present? Let's check. Nope. If no, it produces oxygen gas. So I'm going to get oxygen gas forming. Now this one's a little bit more tricky. I'm going to get oxygen gas forming from these hydroxide ions. So what's going to happen is my hydroxide ions, my OH minuses are going to form some water, some oxygen, and they're going to have to release some electrons as well. Okay, this looks horribly unbalanced, so let's just do this really quickly. I am going to need to put a 4 just here, and a 2 just here, and a 4 just there. Let's just check in and balance that up. So I've got 4 oxygens over here, 2 lots of 1, O2, yep, oxygens are balanced, 4 H's, 2 lots of H2, that's 4 hydrogens, that's brilliant. I've got 4 lots of that minus, that negative charge there, and 4 negative electrons. So what's going on with my hydroxide ions? Well, they are losing electrons, therefore they are being oxidized. Okay, so what are you going to see here? Well, at the cathode, you are going to see copper metal forming. And at the anode, you are going to see oxygen gas forming. Okay, so just remember, it all boils down to these rules up here. At the cathode, the least reactive thing goes first, so that's a reactivity series 1. And the anode, there's just one question. If there's a halogen ion present, something like a chloride ion, that goes first. If not, then you produce some oxygen gas from your hydroxide ions. Thank you very much.